Hey, welcome. Have you ever stared at a spreadsheet and your eyes just glaze over? It's just a blur of numbers, right? Well, today we're going to fix that. We're taking a really dense weather forecast and we're going to learn how to pull a clear, compelling story right out of all that data. So let's dive in. Okay, here it is. At first glance, it's just a wall of numbers. Hundreds of data points stretching across dozens of cities. It's messy, it's complex, and frankly, it's enough to give you a headache. Yeah, I know it looks super intimidating, but what if I told you that that wall of numbers is actually hiding a dramatic story? A story about a major cold front sweeping across the entire country. I promise, by the end of this, you're gonna see it just as clearly as I do. So, how are we gonna do that? We've got a simple five-part game plan. First, we'll decode the table's structure. Then, we'll figure out the key metrics. After that, the fun part. We'll follow that cold front right across the US. Then we'll dig into why this data actually matters. And finally, we'll wrap it all up with your new data superpower. All right, first up, section 1, decoding the data table. Before you can read the story, you've got to know how the book is laid out, right? So let's get our bearings. So if you strip away all that noise, the structure is actually pretty simple. It's organized by region, east, central, and so on. Inside each region, you've got the cities. And for each city, you get a 15-day forecast. It's just region, then city, then day. That's it. That's the whole framework. Okay, let's jump into section 2, the key weather metrics. Now that we know the layout, we've got to learn the language. These are the specific numbers, the vocabulary that hold all the most important clues to our story. All right, the first and probably most important term here is DEV, which is short for deviation from normal. This little number tells us exactly how unusual the temperature is. A big positive number? That could be a heat wave. But a big negative number? Well, that's our signal for a major cold snap. That's our clue. That's the number we're hunting for. Next up, we've got HDD, or heating degree days. Now, the absolute easiest way to think about this is like a heating score for the day. The higher the HDD number, the colder it is, and the more energy people are going to use to heat up their homes and offices. A score of 0 just means you don't need the heat on. And just to show you how extreme this can get, take a look at this. On day 3, Minneapolis has an HDD of 69.5. That's not just put on a sweater cold. That's the kind of intense cold that puts a massive strain on the energy grid. And, there's always an opposite, right? That's CDD, or cooling degree days. It's the same basic idea, but for heat. The higher the CDD, the more energy is getting cranked out for air conditioning. We're not going to see much of this in our cold front story, though. So let's just put it side by side to make it super clear. HDD measures cold and heating demand. CDD measures heat and cooling demand. They're really just two sides of the same energy forecasting coin. For the story we're chasing today, though, we're all in on HDD. Okay, now for the really fun part. Section 3, following a cross-country cold front. We've learned the layout, we've learned the language, and now let's actually read the story as it unfolds, all the way from the Midwest to the East Coast. And here we go. On day 3, just look at the DEV column for the central cities. Minneapolis is a staggering 27 degrees colder than it should be. Chicago's not far behind at 25 degrees below average. This is it, folks. This is the opening chapter of our story, a full-on Arctic blast hitting the heart of the country. All right, fast forward to day 4. You can see the cold getting even deeper and pushing south and east. St. Louis is now almost 28 degrees below normal. And look, you can see the front edge of it just arriving on the East Coast. New York is already 13 degrees colder than average. You can literally see the wave moving across the country. And boom, by day 5, that cold front has just slammed into the East Coast. New York is almost 15 degrees below normal, and Washington, D.C. is over 16 degrees colder than it should be. So there you have it. From a wall of numbers, we've just tracked a massive weather event clear across 1,000 miles. And if you want to understand the sheer scale of this thing, just look at this comparison. On the exact same day that Minneapolis is averaging a brutal negative 4.5 degrees, Phoenix is a beautiful, balmy 67. This isn't some little local cold snap. This is a massive continent-spanning event. Okay, so we found the story, which is cool, but why does it actually matter? That's what Section 4 is all about, connecting this data from power grids all the way to your own wallet. Well, it turns out this data has huge real-world consequences. You've got energy companies using these exact HGD forecasts to predict demand so they can prevent blackouts. Commodity traders are watching this stuff to bet on natural gas prices. And for millions of people, these numbers translate directly into higher or lower heating bills.
And that brings us to our final section, your new data superpower. Because what we just did, it wasn't some kind of magic trick. It's a simple, repeatable method that you can use on pretty much any complex set of info.
So here's the 4-step playbook. Number 1, scan the structure. Get your bearings. Number 2, define the key terms so you know the language you're reading. Number 3, find the pattern. Hunt for the extremes, the outliers, the narrative. And fourth, and this is crucial, always ask so what. Connect that pattern back to the real world.
So, the next time you're faced with one of those spreadsheets that looks like a wall of numbers, just remember this process. Look for the structure, learn the terms, find the pattern, and ask why it matters. Because inside every single data set, there's a story just waiting to be told. The only question left is, what story are you going to find?